Good morning to all. Welcome to my YouTube channel. And today I am going to discuss half an hour chemistry, which I will be doing on daily basis. I will be giving idea. I will be discussing few problems on daily basis for 30 minutes. So today I will be discussing about a topic of organic chemistry, that is conformers or conformations of alkane. So in this topic, we will be discussing today about the different conformers that are possible for alkanes, and considering the example of CH3 and CH3, that is ethane. We know this thing that we assign to this carbon atom as the first carbon and this carbon atom as the second carbon atom. In this case, what happens? We analyze the molecule along this C1-C2 bond length. When we analyze the molecule along the C1-C2 bond length, there is a need to define the front carbon atom and the rear carbon atom. So in this case, in conformations, we decide that this particular arrangement, this particular pattern, which we indicate, where I am indicated the dot and followed by three lines which are larger in length, that indicates, this indicates the front carbon atom, and circle this and this indicates rear carbon atom. As per the concept of isomerism, we want to say this thing, that the C1-C2 bond cannot be said to be completely freezed, as it is possible in case of carbon-carbon double bond. So we want to say this thing, that the CC bond length, there is a possibility that the molecule can be rotated along the carbon-carbon bond length. Due to this rotation possible, we observe that there are infinite structures that are possible, which we call as the conformers, which differ with respect to their arrangement, the relative arrangement of the groups, which differ with respect to their stability. So this is the convention that we are following. This is the front carbon atom and this is the rear carbon atom. To the front carbon atom, 3 bonds have been indicated over here, and to the rear carbon atom, 3 bonds are indicated over here. So if we want to draw the structure of ethane molecule, it is possible that the structure of ethane will be what? It will be like this. This hydrogen, 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 we are indicating to the front carbon atom and to the rear carbon atom. This is the arrangement of the molecule which we call as ethane. In this case, this hydrogen and this hydrogen bond that are present, we say that this is at an angle of 60 degree, which is also called as dihedral angle. इसको हम क्या बोलते हैं? We call it as dihedral angle. And if suppose I rotate it, but if I rotate the front or the rear carbon atom, what happens in this case? We say that there is another form that is possible for the molecule, and that particular form can be represented in this way as I am representing. This is said to be the staggered form of the molecule, and this is said to be the eclipsed form of the molecule. Staggered का मतलब the groups are at maximum distance from each other, and in the eclipse form, this particular carbon atom and the rear carbon atom, the front carbon atom, the bonds which are present in the front carbon atom, they are eclipsing the bonds which are present with the rear carbon atom. So this is staggered form and this is the eclipse form. Here, if I ask you what is the dihedral angle, the dihedral angle is 0 degree. So if we discuss about the stability, इनकी stability के बारे में बात करें, so definitely the staggered form will be more stable because of the presence of the groups at maximum distance from each other. But in the eclipse form, what will happen? This carbon hydrogen bond and the rear carbon, this hydrogen bond, Since they are making a diagonal angle of 0 degree, they are closest to each other. The bonds which are present, the CH bonds that are present, which are close to each other, creates a strain in the molecule, which we call as the torsional strain. So, which strain is present in this case? We say that there is a torsional strain in this case. So, because of the torsional strain, we say the stability order will be the staggered form will definitely be more stable than the eclipsed form for the molecule of ethane. Is it clear? So if I say how many conformers are possible, I have drawn the extreme conformers of ethane. But if I say that what are the intermediate conformers in this case, जो भी intermediate conformers होंगे, they all will be said to be the conformers. It means it is said to be having infinite conformers. If I rotate it by an angle of 1 degree, 2 degree, or any other angle other than 1 degree, 2 degree, between 1 degree and 2 degree, it will create different conformers which we call as the जो conformers होंगे वो इनके बीच में लाई करेंगे ये दोनों क्या हैं both of them are extreme conformers. Similarly, अगर हम प्रोपेन मॉलिक्यूल को एनालाइज करते हैं तो प्रोपेन मॉलिक्यूल में एज वी ऑल नो दैट देयर आर 3 कार्बन एटम्स दैट आर देयर और इस 3 कार्बन एटम में ये फर्स्ट कार्बन है ये सेकंड है ये थर्ड है चाहे हम दूसरी तरह से नंबरिंग कर लें एंड इफ वी draw the conformer of this along the C1-C2 bond length or C2-C3 bond length, it means the same thing. But if I consider the C1-C2 bond length, it will be having to this particular carbon, I say that there are 3 hydrogen atoms that are present like this, and to the rear carbon atom there are 2 hydrogen and 1 methyl group. So I am writing 1 methyl hydrogen and hydrogen like this. So in this case, there is another possibility where the CH3 and H will be eclipsing each other and that will create the eclipse form of the molecule. So in this case, I'll get the conformer as H, H, H. So on rotating it either to the left side or to the right side, the other conformer will be this one. What is this form? These are the 2 forms which we have written, the extreme conformers of the molecule that is butane. They will definitely be different with respect to their stability. It is because of the torsional strain that is present. The torsional strain is created because of the bonded pair of electrons. And those bonded pair of electrons which are closer to each other. Like in case of eclipse form, this CH bond and this CH bond, the repulsion between these bond pair of electron will create this strain, that is torsional strain. So in the other thing is this, that there are other strains that are also present in the molecule. We will analyze it through another example, that is the example of butane, that is N-butane. So if we consider the structure of N-butane, that is CH3, CH2, CH2, CH3, this is 1, 2, 3, 4. If the molecule is analyzed along the C1-C2 bond length, or it can be analyzed along the C2-C3 bond length. It can be analyzed along both the bonds. The rotation across the carbon-carbon single bond is actually not freeze and is also not completely free. There will be the difference in the potential energy of the 2 forms that we are drawing. If I say which one of the staggered form and the eclipse form will have the higher potential energy, the one which is having the lesser stability. The lesser stability is possessed by the eclipse form, therefore it will be having higher potential energy. Is it clear? The next thing is that if we consider the molecule of butane and the molecule is analyzed along the C2, C3 bond length. So we say that one of the conformer for this molecule is CH3, H, H. Along this C2, there are 2 H and 1 CH3. Along the C3, again there are 2 hydrogen and 1 CH3. And I have represented the structure in this way. In this case, if I rotate it by 60 degree, I will obtain another conformer. Here it will be CH3, H, H. If I rotate it This is the eclipse form that is obtained. So what I am doing actually, with respect to this front carbon atom, CH3, H and H, these bonds, these atoms are kept fixed. I am rotating the rear carbon atom such that the CH3, which was earlier making an angle of 60 degree as a dihedral angle, is now present in the eclipse position over here. I can further rotate it by 60 degree to obtain the other conformer, and that will be CH3, H, H, H and H. What is this? This is the another form which is said to be the staggered form that is obtained. Again rotating it by 60 degree, it will be CH3, H, H, another form. Again rotating it by 60 degree will give you another conformer, and that conformer will be H, H, CH3. I think it is clear. And lastly, there will be one more conformer which we can draw and we can analyze the stability of these forms, and that will be अब हमें क्या करना है, हमें इन 5-6 के 6 स्ट्रक्चर्स, दिस इज फर्स्ट, दिस इज सेकंड, दिस इज द थर्ड वन, this is the fourth one, this is the fifth one, and this is the sixth one. What we have to do, we have to compare the stability of these conformers. First thing is, because of the torsional strain, we know that the staggered form has to be more stable. So definitely in this case, the first form, the third form, and the fifth form will be more stable. So comparing these three forms, we say that in the third form, the two methyl groups which are present, they are present at the anti position with respect to each other. Means they will also minimize the steric strain that is created because of the bulkier groups present close to each other. So being the staggered form, it has minimized the torsional strain, and the 2-methyl group present in the anti position will make this staggered form to be most stable. Is that thing clear? So I can say one thing. As far as the stability part is concerned, the third form is most stable, which is also called as the anti-form. We call it as the anti-form. This third form is most stable, followed by first and fifth. First और fifth जो है, उनकी stability क्या है? They are equivalent, they are equally stable. After that, if we consider the second, the fourth, and the sixth form, it can be seen that there will be maximum torsional strain in the sixth form, as it is the perfectly eclipsed conformer of N-butane. But the fourth form and the second form, they are said to be partially eclipsed form of the molecule. So we can say third is most stable, followed by first and fifth. After that, what we will be saying, second structure जो होगा वो fourth structure की stability के बराबर है, और least stable conformer कौन सा है? That is sixth one. I think clear है? So these are the conformers which we have drawn for which molecule, that is N-butane. But butane can also be analyzed along the C1-C2 bond length. In that case, to the first carbon atom there are 3 hydrogen atoms present, and to the second carbon atom there are 2 hydrogen and 1 ethyl group that is there. If we tend to write the conformer along the C1-C2, it will be CH2CH3, H, 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 and this. And the another conformer will be the eclipse one, where the C2H5 and hydrogen atom will be present in the eclipse position. So this is the analysis along the C1-C2 bond length, and this is the analysis along the C2-C3 bond length, and we have compared the stability of these conformers also. In the next lecture, I will be discussing about the conformations of cyclohexane, and we will be doing the problems of the previous year's IIT JEE and NEET papers related to conformation analysis. Thank you.